Hello all of you. Today we'll learn on rotational mechanics, a very important concept, and the concept being how to relate L, which is the symbolic representation as you know, or we can say the analogy for angular momentum. We use an acronym for angular momentum, which is L, and we define L as r cross mv for a particle, and we can very well verify that this L will change to L is equal to LCM plus R cross MVCM when we are talking for any particle or body about a point, where LCM being the angular momentum about center of mass frame. But the point which I want to raise today is, can we use L vector is equal to I into omega vector if is given L is equal to I into omega. There is a general misconception which I would like to clarify in this segment of our lecture. Whenever we do find L is equal to I omega, what in general we refer it to is a quantity which is vector. But L is equal to I omega is certainly not a vector quantity. What is camouflage in this equation, which can be very misleading at times, is this L is actually what to us? This L is L about an axis, or as we can say, this is angular momentum of a body or particle z component. What I mean to clarify today is to be through a diagram manifested. Let us take a body here. All of you please concentrate over it. I am taking a body, a three-dimensional body. This is z-axis to me, this being my x-axis, as we ought to be in right-hand frame, you know. This x-axis, this is y-axis, this is right-hand frame to us. I wish calculate angular momentum of this body about O. This is O to us. Angular momentum of this body about O. How can I verify or calculate angular momentum? Simply what I am to do is I am to first locate a point. Because angular momentum from where we are coming, the baggage that we are carrying, where from we are coming, which stemming from the fact L is equal to what to us? R cross mv. So L is equal to R cross mv is predefined in the previous lecture. Here what I deem fit is to take this as what are in Ano, and this is to be then manifested in the form that we want here. What is that to be? Is to from here gotten what is L for a three-dimensional body which is being rotated about a fixed axis. So for three-dimensional body, we don't have a formula in one shot. What we then do, we calculate L for a particle taking help of the formula that we have derived in the previous classes. L is equal to R cross mv, we know it very well. We select a particle of mass mi. What is this to us? This is ith particle. Ith particle, and what is mass of this ith particle? Mass of ith particle is being taken over here as mi. What from here I am to find is Li. What will be Li is obvious. Taking a cue from this formula, Li is what to us? Li will be Ri cross mi vi. Li will be Ri cross mi vi. Now vi is velocity of ith particle, mi is mass of ith particle, and Ri is the position vector of ith particle. As you can see from here, what is the depiction to you? Mi the ith particle. Ith particle is the particle which is one of the particle that the system encompasses. Ith particle is housed by system. This is the particle which is rotating, and as it is rotating at this point in time, velocity of this particle will be directed into the green ball. So what I write for On and Ri prime vector, let us say this is Ri prime vector to us and this is On vector to us. Ri can be broken in On and Ri prime vector. So let me elaborate it by writing it as On plus Ri prime vector. This is the form which Ri is to shape to. You can see for yourself This is by the vector addition. And what is vector addition? The triangle law, which we have studied long back during the initial phases of physics learning. So On plus Ri, Ri prime is to get me Ri. Cross it with Mi, Mi Vi, and Vi is known to us. Vi is in which direction? Vi is in the direction, as of now, of course. As of now, Vi is directed into the board. You know, Vi will keep on changing its direction. So for now, Vi is directed into the board, which is to get me a know on what is the direction for On cross Mi Vi. Please get a note on. Now I'm into expansion. Expansion of this form in two compartments, and they being On cross Mi Vi and Ri prime cross Mi Vi. I wish you get me the direction of On cross Mi Vi. See, On is this vector to us, and Mi Vi is into the board. If we want to know the cross product known to you, then we'll have to bring the two tails together. That is exactly what I'm into doing. I'm bringing the tails together. So this is On vector, this is Mi Vi vector. If I am to rotate my forearm from On to Mi Vi, then I get the direction of that vector towards me, which is for us as depicted on board, direction for minus y axis. So we get from here when Mi Vi in the direction minus of j cap, where j cap is the notation for unit vector, in the direction of in the direction of y axis. Now see for yourself, if next we are to find on the direction of Ri prime cross Mi Vi, Ri prime cross Mi Vi. In which direction is Ri prime? As seen. Ri prime is this vector to us, and Mi Vi, as in the previous case, is directed into the board. Now I curl my elbow, you say, or forearm from Ri prime to Mi Vi. When I curl my fingers, I get the direction of vector in positive z, which can be marked vectorially as k. So we get the second one as Ri Mi Vi in the direction k cap. See for yourself, class. All of you please pay heed to what is being over here depicted. If you look into the two equations, the two compartments out here, first one is to say that there is a vector which is directed towards the axis of rotation, which is minus j cap for this particle, and the second one is the vector which is directed along the axis of rotation. So one is towards the axis of rotation and the other is along the axis of rotation, and this is no exception to the particle that we have taken. Why I'm saying this is no exception, because this holds true for any particle whichever is to be taken. Whichever particle you take that the body is comprising of, you will get two vectors associated with the particle. One will be towards the axis of rotation and the other is to be along the axis of rotation. Now mathematically we are hamstrung on getting what will be the vectorial sum of the first factor. Why I say mathematically we are hamstrung? Because what we have to find over here, think about it. We are not to limit ourselves for a particle. We took this study in order to get angular momentum of a body which is made to rotate about a fixed axis. And for that, as it was not possible for us to get in one shot, what we did, we took help of whatever we had studied in the other classes. And that was take a particle and go for integration. So I have taken a particle. After taking the particle, I got two factors, one being along the axis of rotation and the other being towards the axis of rotation. As far as along the axis of rotation is concerned, we don't have any qualms. And I'll come to it later. For now, first things first, which is what about the one which is directed towards the axis of rotation? Now think of the case which is directed towards the axis of rotation. Towards the axis of rotation for this particle is in which direction? Minus g. Towards the axis of rotation for this particle is in which direction? Is in the direction minus g. As you can see from here, is in the direction minus g. If I take a particle which is to the other side of y-axis, let me take a particle which is out here, other side of which axis? Y-axis. And then ask you the same question. Tell me for this particle, what will be the direction for ON cross MIVI? Now for this particle, as it is to the other side of z-axis, velocity of this particle will be directed out of the board. So velocity is out of the board, and this is the direction of velocity. My right forearm is manifesting direction of velocity for the particle which is to the left of z-axis. So this is the direction of velocity, and then comes the term ON. ON cross MIVI. ON remains the same as you know. So this is ON and this is the direction of velocity. Now I am to rotate. Rotate from ON to MIVI. If I curl my finger from ON to MIVI, I get the direction which now is to pontificate not in minus g but in plus g. Which of course is an endorsement on taking any particle, first factor will direct towards the axis of rotation. And this is something which is a hamstrung to us because we are mathematically challenged. How are we mathematical challenge? We are mathematical challenge on the front that we will not be able to find summation of vectors which are changing their direction. It will be an onerous ask. By the time we are able to calculate what happened, it must have got changed. So everything will go in vain. What we are to over here get to is summation of vectors which are continuously changing their direction, which we are, as I said already, no mean mathematically to find over here, will fall beyond the ambit of IIT preparatory course. So that is falling beyond the purview of IIT preparatory course. We say that we are in no position to find summation for all the particles which goes into forming this body when it comes to first factor, because first factor will be in actual summation on vectors which are continuously changing their direction. As we will not be able to sum, so we are very surreptitiously from here, very surreptitiously what we will do, we will drop the idea, we will literally drop the idea of finding summation of Li vectors. What was Li? Let me remind you. Li was the acronym for angular momentum of ith particle about O. Okay. Now we calculated Li and we were having an aspiration to calculate it for the body per se. So we went for summation. When we are summing, we find ourselves wanting on the first factor, which is this to us. We cannot sum the first factor. Why? Because the vector which is continuously changing its direction. We surreptitiously drop the idea of calculating Li summation and go for what is within our reach. And what that being? That being the second factor. How is second factor within our reach? How can we say that second factor we rest easy on? You know how? We can say second factor we rest easy on owing to the fact that taken any particle, let's redo, take any particle and see for the direction of the second factor, which is what to read? Ri prime cross MIVI. Ri prime this way for the particle that we have taken for a study initially, this way, and MIVI into the board, bringing the tails together. Ri cross MIVI we got in the direction z-axis. Let us take another particle as we took in the previous case. This particle out here. For this particle, MIVI is outward, right here. So MIVI is outward, and Ri the same, which is as we took for the particle when we went for the first read. So this is Ri prime, the new Ri prime, and this is what to us? This is Mi Vi. This is Mi Vi. Quite a over here I'm into choreography. Physics at times make you choreographer as well. So this is Ri to us, and this is what to us? Mi Vi. Now I am rotating my elbow from whatever being asked, that is Ri prime to Mi Vi. So I curl my finger for the manifestation. Ri prime to Mi Vi. I get the direction, no exception from what I got for the other particle, which substantiates my point. And that being second factor, we can rest easy on. How we can rest easy on second factor? Because second factor is well within our reach. That being owing to the fact that for second factor, direction remains the same. Direction is not changing. And if we have got vectors of which direction is not changing, then we can go for the summation, assuming it to be doing as good as a quantity scalar. So what we do over here, we go for summation of this part. Summation of this part, I'm writing it over here. Ri, Mi, Vi. Summation possible owing to the fact class. Owing to the fact that the direction over here is not to change with particle. Direction is not subjective. In the previous case, direction was subjective, which was the bone of contention. Here, direction is not subjective. Direction for every particle is along, for our case, as shown on board, along positive z, or you can say the axis of rotation. Let us see what we get when we sum it over all the particles. Ri prime, Mi Vi. Firstly, how did I get Ri prime cross Mi Vi as Ri prime Mi Vi? Owing to the fact that the angle between Ri prime and Mi Vi being 90 degree. So we got Ri prime cross Mi Vi as Ri prime Mi Vi. After of this, we are to sum it. Sum it from where to where? From I is equal to 1 to I is equal to n. We are privy to the fact that Vi can be, taking a cue from circular motion, Vi can be marked as Ri prime into omega. And we are summing this factor from where to where? From I is equal to 1 to I is equal to n. If you meticulously note what we are eventuating this equation to, we get it as Mi Ri prime whole square into omega, right? Yeah, right, all of you, right, class? Ri prime square, Mi. Are you getting any deja vu, the feel of deja vu, anything nostalgic or nauseous? If it is nauseous, say so without any flinch. I think you should be getting something, some deja vu out here, something to recollect. You may be hit by nostalgia is what I presume. This factor, nobody is greenhorn to. This factor, nobody is greenhorn to. You know why I'm saying so? Because this factor we have studied, I think recent past we have, wherein we said that when we sum over Mi Ri prime square, where Ri prime is the perpendicular distance from the axis of rotation of the particle. So when we sum it over, then we get it as, or we read it as, moment of inertia about that axis. What we then get to see from here, that omega being constant, omega is common, summation falls on whatever has got in its to see I. So I is to be seen with M, I is to be seen with R prime. Therefore, we are summing it over the terms Mi and R prime, Mi and Ri prime you may say, and from where to where? From I is equal to 1 to I is equal to n. This is what is to get you moment of inertia. Moment of inertia of what? Of this body about the axis of rotation, and omega as it is being dropped, omega is untethered, unscathed, omega being followed. This leads to getting what will be one of the component of angular momentum. Please don't lose sight of that we have dropped the first factor. We are going only with the second factor because first factor summation was beyond the ambit of IIT preparatory course. So we surreptitiously did drop and went for the one which was well within our reach, and that was the second one. When we are dealing with the second one, then X and Y are not to partake. Only Z be partake. Why will only Z will partake? Because first factor, if you look, first factor was getting you a vector, and that vector was continuously changing its direction for any particle. So that vector for any particle will lie, think about it, that vector will lie in which plane? It will lie in XY plane. So that part has got no trucks with which direction? With Z direction. Because that cannot produce any effect in Z direction. In Z direction, effect can be produced only by the second factor, which is what we have taken. So second factor taken will have then no trucks in equal breadth, in same breadth, with equal measure. We can say that second factor will have no trucks, will have absolutely no inkling on what it is to get you other than Z direction. It will get you everything along Z direction. It has got nothing to do with X and Y direction. So second factor is getting you angular momentum along which direction? Along Z direction. Whereas the first factor would have gotten you, if it was in our capacity to find it, first factor would have gotten us angular momentum which falls in the plane XY. So what we can say about the one which is in our capacity? The one which is in our capacity is the angular momentum of the body. About which axis? About Z axis. Z being the axis of rotation. So we may say this is angular momentum about the axis of rotation. This is angular momentum of the particle about the axis of rotation. What does this suggest? This is one of the component of angular momentum. This is not angular momentum in whole sum. This is not angular momentum in whole sum. I reiterate. This is one of the component of angular momentum. So which component is being? The component which is along the axis of rotation. In our case, that being which axis? That being Z axis. So when we write L is equal to I into omega, basically what we are reading for is one of the component of L. We can also mark it as Iz and omega Z. That means angular momentum of this body about Z axis is moment of inertia of this body about Z axis into omega about the same axis, that being the axis of rotation to us. We cannot say that this will lead to L vector is equal to I into omega vector. When we can make that claim, we can state that claim if is Lx and Ly individually 0. If they are 0 individually, if Lx being 0, Ly being 0, then we can say that as we have got only Lz, it can also be treated as a vector quantity. Till the time we get both 0, both over here being Lx and Ly 0, we cannot stake claim to the vector relation. But I'll ask you a question over here, an intriguing question, which is, in which case, think about it, class, very enlightening, inciting. Physics, you'll get an insight on physics. In which case, it'll evoke a thought. In which case, we can, if given Lz is equal to Iz into omega Z, in which case, this equation can transcend to the vector relation. If I want to get the vector relation, and I want to qualify reading it as vector relation as well, so which case will make me get it? Which case will transcend this scalar equation or component of angular momentum to this vector relation? Is there a possibility? There exists a possibility or not, is what my question. There is where my concern lies. And to which the answer is, certainly there exists a possibility if we can take a system for which summation of first factor, reminding you on what was the first factor? The contention. Why? Because there was no mean. We were mathematically hamstrung. There was no mean. We were challenged mathematically to find summation of the first factor, as first factor was a vector which was directed towards the axis of rotation and it was changing its direction continuously. So first factor we did drop, if you can recollect. At that time I asked you to drop it. Now I'm asking you to bring it back. Factor it in. If we are factoring it in, if we are reconciling on it, then what we get to see? We get to see L z is equal to I z into omega z can transcend to L vector is equal to I into omega vector, subject to summation of first factor being 0. And when can summation of first factor lead you to what you desire? Summation of first factor will lead you to what you desire only for the case when body is symmetric about axis of rotation. If body is symmetric about axis of rotation, then for every particle to the right, there's a particle to left. For every particle at 4, there's a particle at back. So for every particle, there's a counter particle. And if we sum for those particles, the pairs, then we get summation for all such particles tantamounting to 0, a null vector. So if the body is symmetric about the axis of rotation, then first factor will tantamount to, when summed for all the particles of the system, first factor will tantamount to a null vector. And if first factor is tantamounting to a null vector, whatever was our contention got addressed. Now we can say very well that Lz is equal to I into omega z will translate to L vector is equal to I into omega vector. Why so? Because we have just now proved that Lx and Ly both are 0. So this is a very important concept, by the way. Previously was to be found in one of the book. Later they scrape it for reason best known to them. But this is a very good concept and you can expect questions being on this articulated in advanced examination. See you the other time. Bye for now.